All right, it's time to get ready for our Unit 6 test over cubics and cube roots. And so the first one says list the attributes of the cube root of x and domain, range, symmetry, x-intercept, y-intercept. So we're going to find the domain, the range, the symmetry, the x-intercept, and the y-intercept. And so domain and range of every single cubic or cube root is all real numbers, so that's going to be true every time. My symmetry is it's rotational, 180 degrees around the inflection point. On this one, that's, 0, 0. All right, because this graph of a cube root starts at 0, 0. That's the starting point. The inflection point is going to go horizontally like that. Then my x-intercept, it goes through at 0, and my y-intercept, it also goes through at 0. Now let's attributes of the cubic. So cubic looks just like this except vertical. So it's going to start 0, 0 at the inflection point and go vertically. And so my domain and my range again are all real numbers. My symmetry is the same as the cube root, rotational, 180 degrees around 0, 0. The x-intercept and the y-intercept again goes through 0. Find the inverse of the following. So we're going to switch the x and y and solve for y. So we're going to have x equals 2, y minus 4 plus 3. And so we'll subtract 3 first. X minus 3 equals 2, y minus 4. Oops, I forgot the cubed. And then we'll divide by 2. And so x minus 3 over 2 equals y minus 4 cubed. Then we'll get rid of the cube by taking the cube root. X minus 3 over 2 equals y minus 4. And then we'll add 4 over. X minus 3 over 2 plus 4 equals y. Moving on to the next page. Number 4, we want to find and graph the inverse. And so I don't want that graph, I want the inverse. And so we'll start off by switching my x and y again. X equals the cube root of y plus 3 minus 1. We'll add 1 over. And then we'll get rid of the cube root by taking the cube of it. And then we'll subtract 3. X plus 1 cubed minus 3 equals y. So my inflection point is going to go left 1 and down 3. And we're cubic. There's no stretch or compress. We're going to go over 1, up 1. And we'll go over 2, up 8. 2, 3, 4, 5, 6, 7. Same thing on the left side. Left 1, down 1. Left 2, down 8, 1, 6, 7, 8. Describe the attributes of this graph. And so again, we'll do domain, range, symmetry, x-intercept, and y-intercept. And for this graph, if I were to draw a sketch, it goes left 2 and down 6. So somewhere in that range. And it's tripling. It's being stretched by 3, so it's going to be a lot narrower, but it's going to be something like that. So domain and range again are all real numbers. It has rotational symmetry, 180 degrees around the inflection point, which on this one's -2, -6. And then for the x and y intercept, I'll solve it algebraically. And so for the x intercept, I'll plug in 0 for y and solve for the x. X plus 2 cubed minus 6, we'll add the 6 over. We'll divide by 3. We'll take the cube root of the 2, and then we'll subtract 2. And so in our calculator, I'll press math 4 to take the cube root of 2, and then we'll subtract 2, and -0.74. -0.74. Then the y-intercept, I'll do the opposite. I'll plug in 0 for x and see what the y is. So y equals 3, 0 plus 2 cubed minus 6. And so that's going to be 2, and 2 cubed is 8. So 3 times 8 minus 6. 3 times 8 is 24. and minus 6 gets me 18. Find the inverse. We're going to switch my x and y. And so we'll subtract 6. I'm going to go ahead and do two things at one time. I'm going to subtract 6 and then divide by 5. Now we'll cube it. X minus 6 over 5 cubed equals 1/3 y minus 2. And then since this is in parentheses, I gotta get rid of the 1/3 next. So we're gonna multiply by 3. 3x minus 6 divided by 5 cubed equals y minus 2, and then we'll add 2 over. So 3x minus 6 divided by 5 cubed plus 2 equals y. All right, we're gonna solve this one. So we'll start off dividing by -3, which I believe is 27, -27, and then we'll cube it to get rid of the cube root. And so we're going to cube the -27. So there's my work that I've put in my calculator so far. -19,683, and then we'll subtract 4. So x equals -19,687. Find the inverse, and so again we'll switch the x and y. Subtract 4 and divide by 3. I'll go ahead and do both of them at the same time again. And we'll take the cube root. And lastly, we'll add 1. All right, describe the transformations from x cubed to this. And so this 1/3 is going to be a vertical compression by 1/3. We're going to the right 2, and we're going up 4. Again, we're going to solve, and so I'm going to start by cubing both sides. So we get 4x plus 7 equals 64. And then we'll subtract 7 over, and then we'll divide by 4. I'm just going to double check my work in here. And so we had 4 cubed, and we subtracted 7, and we divided by 4. So 14.25. And again, you can always check that by just making sure you have the right answer. So I'll put in 4 times 14.25 plus 7. It equals 4, it checks. That's my correct answer. The shoulder height of an elephant is modeled by this equation, where T is the age and H is the height. How old is the elephant when its height is 280 centimeters? So we're gonna have the height is 280, and we're gonna solve for the T. And so we're gonna subtract 76 over first, and so we're at 280 minus 76. And then we'll divide that by 62.1. And so that's going to be 204 equals the cube root of t. We divided by the 62.1 already to get 3.29 equals the cube root of t. And then we'll cube both sides. So I'm just going to go ahead and cube my answer to keep it as exact as possible. So t equals about 35.4 years old. Again, we have transformations, and so we've got the 3 in the front, so that's going to be a vertical stretch by 3. We're going to the right 2, and we're going up 5. And then last page. Again, we're going to solve, and so we're going to divide by 5 first. We get x plus 4 cubed is equal to -8. And then we're going to take the cube root, and so x plus 4 equals -2, and then we'll subtract 4 over to get x equals -6. And again, we can check it in our calculator. 5, -6 plus 4 cubed, it does get -40, so we got it correct. Graph the function and describe the transformation. So we're going to have a vertical stretch by 2. We're going to the left 4. And we're going down 1. And so left 4, 1, 2, 3, 4, down 1, that's my inflection point. We are stretching it by 2, so we're going to go right 1 and up 2. And we'll go right 2 and up 16. So it's going to go well off my grid. I'll just put it up here. Left 1 and down 2, left 2 and down 16, so somewhere down in that area. And then solve this equation. So work our way outside in to find this. So the furthest outside is minus 9, so we're going to start off by adding that 9 over. So that equals 11. Then we're going to take the cube root of that. And so I'm just going to keep it cube root of 11, and we'll do that later because it's not a perfect cube root, and so I'll wait to estimate till the end. And so now I'll subtract 15 over 45 minus 9x to the 1/3 equals cube root of 11 minus 15. And then we're going to cube both sides, so 45 minus 9x equals the cube root of 11 minus 15, and the whole thing cubed. And then we'll subtract 45, so negative 9x equals all of this cubed minus 45, and the last step will divide by negative 9. And so my x is equal to, now we'll put in the calculator. And so I've got math for cube root of 11, whoops. And then we're subtracting 15, and then we're going to cube it. Then we'll subtract 45, and then we'll divide by negative 9. 236.7. And again, we can check it. One easy way to check it is we can store this as our x and then just put it into the calculator as it is. So 45 minus 9x raised to the 1/3 power plus 15 raised to the 3rd power minus 9 equals 2. And so it checked. All right, and that's it for this test. Good luck. Let me know if you need anything else.